Okay, this is a video 11.2 on arithmetic series. First of all, let's start off by talking about arithmetic sequences, which is actually a concept that's introduced to you in as low as 6th grade. An arithmetic sequence is when you go from one number to the next number and you have a pattern that maintains the same throughout the entire sequence. So for example, from 4 to 7, 7 to 10, how are we getting from one number to the next? Well, we're adding 3, and that's basically all an arithmetic sequence is. Now, the difference between a sequence and a series is that a series, we add everything together. A sequence is just numbers in a pattern. So all we're going to do to change this from a sequence to a series is we're going to put plus signs in between the numbers. So 4 plus 7 plus 10 plus 13 plus 16. The next one, same thing basically, -10 to -4 to +2. The same thing again, but instead with the negatives, of course, it's going to be written a little bit differently, and we're going to put parentheses around the negative numbers just to keep those separate from each other. And the next one's a fraction, so we have 2 over 7, and then 6 over 7, and 10 over 7, and 14 over 7, so you can tell that we're adding 4 over 7 to each number. So then again, we're just going to write that out as a series by sticking those plus signs in between the numbers. Okay, so now that we know the difference between a sequence and a series, let's talk about how you can find the sum of these. So it says S sub n, you say it, S sub n. It's used to represent the sum of the first n terms of a series. And we're going to write down an example underneath here as well. So let's just kind of take a look at that first example that we had talked about up here. So if we have 4 plus 7 plus 10 plus 13 plus 16, and now this is all we can see of the pattern, but it does keep going on and on. So I'm just going to stick a dot, dot, dot after it. Now if we wanted to find S sub 3, all that means is that we're going to take the first 3 numbers in the series and find the sum of them. So the first 3 numbers are 4, 7, and 10. And if we add all that up, we get 21. So S sub 3 would equal 21. That's all that little s with the n means. Sum of an arithmetic series, so again, just what we had discussed a little bit, is S sub n equals, now there's actually a formula for this, n over 2, so n means how many numbers there are. We're going to write all this off to the side, times the quantity a sub 1, which is the first term in the sequence, plus a sub n, which is the last term in the series. Okay, so off to the side we have a little bit of room left here. Let's go ahead and tell what each of these variables mean. The n means the number of terms in the series. So for example, this first one we had up here has 1, 2, 3, 4, 5 terms in the series, so our n would be 5. A sub 1 is the first term in the series. So if we look at that top example again, the first term would be the 4 because it's the first number in the series. And a sub n is the last term in the series. So again, in that top example, it would be 16 because that's the last number in the series. So just by knowing how many numbers there are, what's the first number, what's the last number, we can figure out what the sum of the series is. So let's take a look at an example now using that equation or that formula. So number 1 says find the sum of the first 50 positive even integers. So positive even integers, let's just think about what they're talking about first right now. 50 positive even integers. Positive, of course, meaning above 0. Even, meaning 2, 4, 6, 8. And integers just means that it could be negative, it could be positive, but they are specifically saying positive. So let's go 2, 4, 6, 8, and it's going to go on all the way for 50 terms. Okay, we know that. So let's write out our variables. Our n, which is how many terms are in the series, they're telling us right here, is 50. Our a sub 1, so where does the series start, is 2. And then our a sub n. Now, We got to think about this. If we write down 50 of these numbers, and we're starting off at 2 and we're writing down 50 of them, what's our last number going to be? Well, if we take 50 times 2, because we're only counting every other number, that would be 100. So our last term in our series is going to be 100. So if we wanted to find the sum, so that's what that S stands for, of the first 50 terms in this series, we're going to use this formula right here. N over 2, so 50 over 2, times the quantity, a sub 1, which is 2, plus a sub n, which is 100. Oops, not sure why I wrote 1002. Close that parenthesis off, and then we're going to solve it. So using order of operations, I'm going to add the quantity first on the inside, and I get 102. And then 50 over 2 is just 25, because that's half of 50. And last thing I have to do is 25 times 102 is going to give me 2,550. And that is the sum of all of those numbers. Now, could you have taken your calculator and added 2 and 4 and 6 and 8 and all the way up to 100 together and found this exact same number? Yes, but this is a shortcut. This is an easier way to do that. Now, there is another version to this. If you're given a little bit different information, and this is when you're going to use this, so let's write this one out as well. S sub n equals n over 2, so it starts out very similar to the last one, but this is where it's going to change. 2 times a sub 1, so 2 times the first term, plus n minus 1 times d. Now d is our new variable in this formula. Notice there is no a sub n. You're going to use this one when you don't know what that last term in the series is. So, but we do have something that's different. That is our d. And our d in this is going to be our common difference. Basically, what number is added to the first to get to the next? How do we get from one number to the next? Okay, so our common difference. So you can think about D stands for difference. How do you get from one number to the next? So let's take a look at this next example. It says find the sum of the first 40 terms of an arithmetic series in which A1 is 70 and D is negative 21. So, for example, this is what our series is going to kind of look like. If your first term is 70, and to get from one number to the next, we're going to add a negative 21, what would our next number be? Well, basically, we're subtracting 21, and we get to 49. And we're going to continue to do that. We go down to 28, and then we go down to 7, and then it continues on like that for 40 terms. So we know that our n equals 40. We know our a sub 1 is 70, and we know our d is negative 21. Now, how would you know to use this one or the formula up here? Well, of course, you don't know a sub n. So not as easy to tell as this last one up here was. But we do know how do we get from one number to the next. Now, could we have used that formula right here on this one instead of figuring out what a sub n was that was 100? Could we have used d as 2? That's because that's how we're getting from one number to the next. Yes, and you would have gotten the exact same answer. Just again, another version of the same formula. So let's use this formula up here. S of 40, because that's our n, equals 40 over 2. And then in brackets, we have 2 times my a sub 1, my a sub 1 is 70, plus n minus 1, so 40 minus 1, times my d. Now my d in this case is a negative 21. And then close off those brackets. And then again, order of operations when we're solving this. So let's go ahead and simplify this out. 40 over 2 is just 20, so I'm going to replace that. I know 2 times 70 is 140. And then I have 40 minus 1 is just 39. And 39 times a negative 21 is going to give me a negative 819. Okay, simplifying even further, 140 plus negative 819, and then multiply by 20, we're going to get negative 13,580. Now, you're going to ask yourself, negative? Can this answer be negative? Can the sum be negative? Well, in this case, think about it. we have positive number, positive number, positive number, positive number. So there's 4 positive numbers. And then after that, if we're adding a negative 21 to each of these numbers, it's just going to get negative for 40 terms. So we have 4 terms that are positive, and we have 36 of them that are negative. That's probably going to give us a negative solution. So yes, does that make sense? Yes, it does. Let's go to the back side. A couple more examples. So again, we kind of are thinking about which formula are we going to use, what is our information that's given to us. So it says, find the sum of each arithmetic series. Now, sometimes, let's make a note of this, we may have to find n. Because you're going to notice in either formula you use, you need to know what n is. And sometimes we may have to find out what n is. And I'm going to show you how to do that as well. So in this case, what do we know? Well, I know my first term is 5, so a1 equals 5. I know my a sub n is 95, because they tell me what my last term is. And I know my d as well. I know how to get from one number to the next. How do I get from 5 to 11? I add 6, so my d is 6. Okay, so there's my given information. But what I don't know is what's n. What is n? And we need to know that in order to do either of the formulas that we want to use. So how to do that is you're going to take your a sub n minus your a sub 1. So your last term minus your first term. And then after that, we're going to write out this formula. You're going to divide by d. You're going to divide by your difference. And then once you have all of that, you're going to add 1 to it. And that will give you your n. So let's go ahead and do that. So our a sub n is 95. Our a sub 1 is 5, and then I'm going to divide by d, which is 6, and then I'm going to add 1 to it. So again, using order of operations. First of all, 95 minus 5 is just 90. 90 divided by 6, and then I'm going to add 1. I'm going to run out of room. 90 divided by 6 is going to give me 15, and finally 15 plus 1 is going to give me 16. So there is my n. Now, I have not even used one of the sum formulas yet, so that's just how to get your n, okay? So again, n is 16. We're going to need to know that. So now, let's go ahead and use one of the formulas. I'm going to use the first one. It's a little bit shorter. So s sub 16 equals n over 2, so 16 over 2, times a sub 1, which is 5, plus a sub n, which is 95. So half of 16 is 8. And I know 5 plus 95 is 100. Well, this is the easy one. And 8 times 100, 800. So the sum of that sequence, or that series, I should say, would be 800. Okay? So again, this is very important information just right here, is how to find n. How do we get that? So make sure that that's starred or bolded or whatever you need to do. Let's take a look at this next one. So again, very, very similar to the last one we just did. You know your a sub 1 is 38. You know your a sub n is 2. And you know your d, which is your difference, how to get from one to the next. Now, because we're going down, you know it's going to be negative. 38 to 5. How do we get from 38 to 5? Well, we subtract 3. So it's going to be a negative 3. It's just like adding a negative 3. Subtracting 3 is the same as adding a negative 3. Now again, we don't know what n is, so let's go ahead and figure that out first. So again, I'm going to do a sub n minus a sub 1, so 2 minus 38 over my d, which is a negative 3. So that's going to give me a negative 36 over a negative 3. That's going to give me a positive 12. Now remember, all these numbers are always going to come out positive because it doesn't make any sense at all for your number to be a negative number because we're figuring out how many numbers do we have in this series. And then finally add 1 to it. Oops, I forgot that part here. Let's go ahead and just kind of sneak that in there so that you have it. Don't forget about it. And we get 13. Reason why we have to add 1 in there is because when you're doing this, also the subtraction, you actually accidentally get rid of a number that we kind of need in order to get the correct solution. Let's use the first formula from the other side again. So s of n, which is 13, equals 13 over 2 times your a sub n plus your a sub 1, so 38 plus 2. 13 over 2 gives me, what, 6.5? And 38 plus 2 is 40. So 6.5 times 40 is going to give me 260. And there's my solution for that one. Okay? Last one, last example. Number 4. Find the first three terms of the arithmetic series in which a sub 1 is 13, a sub n is 157, and then s of n is 1445. Now, they're not giving you the n, and they're not giving you the d. All we know is that our sequence starts at 13, and then goes on for so many numbers, but we don't know what that is, and it ends at 157. And we know that them added together equals 1445. Okay? So first step we're going to do this in a couple different steps, is we are going to find n. So let's write this out step by step. We want to know how many numbers are in this series. So, and again, because we're trying to find the first three terms. We already know the first one, we just need to know the next two, but we need to know how to get from the one to the next. So, formula from the other side, s of n equals, and I'm just going to use the first one again, n over 2 times a sub 1 plus a sub n. So I'm going to plug in what I know. I know s of n is 1445. Don't know my n, so I'm going to leave that blank. I know my a sub 1 is 13, and my a sub n is 157. Now what we're going to do is we're going to solve for n. So I have 1445 equals n over 2 times, now 13 plus 157 is 170. I can cancel 2 out with 170 because remember this is just like we have a fraction times a fraction. You can cross cancel. I'm going to divide 2 and divide by 2 on this side. I get 85. Continuing on, I have 1445 equals just 85 times n. Divide by 85 on both sides. And finally, n equals whatever 144 divided by 85 is, which actually just happens to be 17. So that means there's 17 numbers in this sequence. Okay? Now, next step. Now remember, we're looking for the first three terms in this sequence. All we know is there's 17 terms in here. We don't quite know what they're counting by yet. So we need to find d. So, using my second formula. Little bit different than my second formula, but almost the same. A sub n equals a sub 1 plus n minus 1 times d. Now, this is kind of another formula that I'm throwing at you, but this is the only time you are going to use it. So we didn't write it out formally in the front of this note sheet, but this is the only time you're going to use this. So this is when we're finding d and we know all this information, or when you have a problem that's like this. So a sub n we know is 157. I'm just filling in what I know. A sub 1 is 13. I know my n is 17, so 17 minus 1, and then I don't know my d, so my d is going to stay a d. So solving this, 157 equals, now 13 plus, I'm going to simplify 17 minus 1 just as 16d. I'm going to subtract 13 because I'm trying to get d by itself. And that's going to leave me with 144 equals 16d. Divide by 16. And it looks like d equals 9. Now, step 3, last step, and we are done. This is basically just writing out our answer. The question asked us again in the beginning, find the first three terms of the sequence. We want a1, we want a2, we want a3. So a1 in this case we already knew was 13. We already had part of the answer done. Now to get to a2, we're going to take our 13 and add 9 to it. Remember, that's why we did that. That's why we needed to do all of these steps to find this 9 right here. So 13 plus 9 is going to give me 22. And then to get to the next one, we're just going to add from 22, add 9 again, and we get 31. So our answer is 13, 22, and 31. And again, you can either write out your solution like this here, or you can rewrite it a little bit simpler as well. I know that this is wrong, but you have your note sheet, so take a look at that for the problems that you need to do.